back here. So just continuing on, we're going to be looking to find out all the exact value of these trig functions that are in this box, but just given the information that's on the top. So notice that we're given a trig ratio of sine, and it's equal to 3/5, and I'm telling you that is located in quadrant number 1. So what we're going to have to do is sketch out that triangle in quadrant 1, because remember we're talking about right triangle trig. So if I was to just roughly sketch out a triangle in quadrant 1, remember it always comes out from the origin, out into the quadrant, and then down to your x-axis. So this would be the right angle here, and this is the theta that we're referring to. So if we look at the information we're given, we are given sine. Well, sine, if you think of SOHCAHTOA, is so. That's the SOH part, so it's opposite over hypotenuse. So that means that this is the opposite value, and this is the hypotenuse value, opposite over hypotenuse. So let's label the triangle as such. Opposite the angle that we have, which is theta. So that's, if you can draw the dotted line across, is 3. The hypotenuse is always the longest side, or also opposite the right or 90-degree angle, and that is 5. Now, we do have to find this other missing length there, and we should know that it's a 3, 4, 5 triangle, but if we don't, we can always use Pythagorean theorem to find it. So you've got 3 squared plus b squared is equal to 5 squared. 9 plus b squared is 25. Subtracting that out, we have b squared is 16. Taking the square root, b is 4. So remember 3, 4, 5 triangle. So let's go ahead and label the triangle with our OH and A, just so that we can have some labels so that we can find the other trig ratios based off this triangle. So you've got opposite, the hypotenuse, and the adjacent. So we want the cosine first. The cosine is ca. So that's adjacent over hypotenuse. The adjacent here is 4, the hypotenuse is 5, so the cosine is 4 over 5. The secant we know is the reciprocal of the cosine, so if we just go ahead and flip that upside down, we've got 5 over 4. Or you can think of it as ca, and instead of a over h, it's h over a, and then do it based off the triangle. So h would be 5 over the adjacent, which is 4. The cosecant, remember, you need the sine. Now, you could actually have done that without drawing the triangle. We know that it's the reciprocal of sine. Sine is 3/5, so we know that it's got to be 5 over 3. Or you could say, instead of o over h, it's h over o. So the h there is 5, the o is 3. The tangent is TOA. That's the opposite over the adjacent, so that's 3 over 4. And then we know cotangent is the reciprocal of tangent. So that would be 4 over 3, just flipping that upside down. Okay, so for this one, we have the cosecant, and the ratio is 13 over 5. And I want to find the secant times the tangent. And once again, we're in quadrant 1. We'll get into a video where we do different quadrants later on, but you'll see how signs will change depending on what quadrant you're in. So we're keeping it basic for right now. So I'm going to go ahead and sketch out a quadrant 1 triangle. Remember, always from the origin out into the quadrant and then down to the x-axis. There's my 90-degree angle, and there's my theta. So thinking about how we would label this, we have to think about cosecant. Cosecant is the reciprocal of sine, and sine is so that's over h. Well, if it's the reciprocal, remember you're flipping it upside down, so it's really h over o. I'm just labeling that there. So I'm going to label my triangle now. The opposite piece here is 5. The hypotenuse is 13. And we don't have this piece right here, so we do need to find the adjacent length because we're going to need that obviously for the secant, because secant is the reciprocal of cosine. So you should know this is also a triple, what that missing length is, but let's say you don't, we're going to go ahead and solve that out. So remember Pythagorean theorem. 5 squared plus b squared is 13 squared. 25 is 5 squared. 169 is 13 squared. So we're going to subtract out of the 25, and you get 144, and the square root is 12. Okay, so that means that's 12. So now we're going to label this triangle OH and A. Opposite, hypotenuse, and the adjacent there. So now let's go ahead and find out what the trig ratios are so that we can actually do secant times tangent. So the secant, remember, is the reciprocal of cosine, and cosine, remember, is ca. So we really want h over a. Well, the hypotenuse there is 13. over the adjacent piece, and the adjacent piece here is 12. And we want to times that by the tangent. Tangent is tela, so that's opposite over the adjacent. The opposite here is 5 over the adjacent 12. So now we want to multiply these. We know 13 times 5, and then 12 times 12. Okay, so here we should have 65 over 144. Right, and that would be the answer to this problem there. Okay. Try another. Okay, so this is the last one we're going to do in quadrant 1. And this time we have the secant. So I'm just going to sketch out the triangle that represents the situation. Remember, from the origin into the quadrant, down to your x-axis, and I'm labeling as such. Now, we have the secant this time, and secant, remember, is the reciprocal of cosine. So that's the piece. So instead of a over h, it's the reciprocal, which means h over a. But it's 2. 2 is actually a fraction. It's 2 over 1. So 2 is the hypotenuse, and then the adjacent side is 1. So let's go ahead and label this. We've got 2 here, and then 1 is on our adjacent side. So we need to still find that missing length there, and we're going to use our Pythagorean theorem to do so. 1 squared plus b squared is 2 squared. We've got 1 plus b squared is equal to 4. Subtracting that out, we got b squared is equal to 3. And then taking the square root, b is rad 3. So this side length is really rad 3. Let's go ahead and label the side length of this triangle in reference to the angle. So we've got opposite, hypotenuse, and adjacent. And then we're going to go ahead and find the trig ratio so that we can actually perform this multiplication problem that the question's asking. So it wants cosecant times sine times cotangent. So we're starting off very basic. There are different ways to kind of go about this, but let's look at the cosecant. Cosecant, we remember, is the reciprocal of sine. So we've got that so in the SOHCAHTOA part. Instead of O over H, it's really H over O. So the hypotenuse there is 2 over the opposite side, rather, which is rad 3. Now, of course, we know that you're not allowed to have a radical in the denominator, but I'm going to leave that for right now because we don't necessarily know if it's going to cross out when we multiply across. So I'm just going to leave it be. We've then got that times the sine. Well, sine, remember, is so that's opposite over hypotenuse. The opposite there is rad 3 over the hypotenuse, which is 2. So you should notice something happening over here already. And then we're multiplying it by the cotangent. Now, the cotangent, remember, is the reciprocal of tan. So that's tela, but instead of O over A, it's A over O. So the adjacent piece here is 1 over the opposite, which is rad 3. So now I'm going to multiply these straight across, and we know that anything the same on the top and the bottom is going to cancel out because technically a number divided by itself is equal to 1. So we know that the 2 over 2 is equal to 1, or it's going to go away, and the rad 3 over rad 3 is also gone. So you're really just left with this last piece, which is 1 over rad 3. Keep in mind you're not allowed to have that, so you do have to go ahead and rationalize. So we're going to multiply by the radical we want to get rid of, rad 3, and then remember on top and bottom, because rad 3 over rad 3 is equivalent to 1, you're not necessarily changing the value of it, just the way it looks. Multiplying across, we've got rad 3 over rad 3 times 3, which is 3, shortcut, right? Or remember, rad 3 squared, cancel out. Or the square root of 9, which is equal to 3. So rad 3 over 3 is the final answer to this problem.